we will first see some basic stuff about how to read it and what we should care about, what should be careful about. And then I have implemented a game, a basic game, and then we will see how we can write its save file, how to save that file, and how to read, how to save that game, and how to load that game and continue our game. So that a very practical example of this I/O operations. So first, let's start with these object streams. So when we are writing file, dealing with the data, currently what we have seen so far is we were able to write character files, which means we can create TXT files. These files are for us to read, and so that a human can read it. But actually, in some cases, we might not need to create files that humans should read. Like you are playing a game, like I don't know, any game you might remember, think of, like maybe you have a player, it has some weapons, some life, and there's a map, there are some other players. Then I want to save this game. Then how can I save it? Like, should I create a file in which I can literally write with a text that humans can read, like, okay, my player is in this location, I have this weapons, this is my life and points, and so on and so. Well, this is not needed because the computer will not, humans will not read it actually. Computer needs it. So and there's this drawback of writing human readable documents, because let's say I have an object of players. Maybe I have some Boolean variable, and then I have to convert it to strings. There's this conversion overhead, and also when I'm loading it, I have to convert it again back from string to whatever data is needed. So what I want to do is I want to create the files as it is written in the RAM. So I want to write it as an integer, and I want to write it as a Boolean or so, whatever it is, and then I want to load it as it is. So this is, and then when we create this file, this will be a binary file, which means that the output will not be readable by us, but actually the computer will be able to read it. And again, we have this object input stream or object output stream. These are objects that we use to read and write to files. And also we use this file input stream. This is their parameters. But again, the same thing exists. There are some other libraries that allows you to write to binary files and read from binary files. We will just see these two of them. But there's some certain issues that we need to be very careful about it when we are processing binary data. Now I will show it with an example, and I would like to take this actually a copy paste from here, and let me do this, and then I'll go to my Java file, and then in that one I would like to we can create maybe one more file in which I'll say binary operations, binary I/O operations. That would be better naming. All right, and let's zoom in a little bit, and then I'll copy paste here with all the issues that it causes. First, I want to write a file, so I will delete these input cases, and I have to import these libraries. That's why I'm getting this error. So I also need to import this, and we need to import this I/O exception. That's all and we. No, for the exam, no, you don't need it. And of course, I should have done this in a main method. So let me public static void main string args. All right, and I just realized that I didn't. I started recording. Okay, that's good. So when we are now, what we are here doing is we are using object output stream to write to a file, and then we create it which takes a file output stream, and then in that one we have some file name that we can give. Once we have done it, of course, not to forget, we open a file, so we should also close that. I will also put that link here. Then when we are writing the file, now the thing that we have to be careful about is, and this part needs really some, we need to be very careful about it, which is whatever the order of data that we write, because we will use in when we are writing, and the type of them. So when we say that write, it's not available. We should say, okay, I want to write. Let's first create some maybe variables. Let's say I want to write these integer x is 5, short y is 10, and then you can do it for Boolean, whatever it is. Let's say true, and you can have string ABC, and you can have float, let's say 0.5f. Okay. Then I want to write this data to my file. So for that one, let's say I will say out dot write. When I say write, I also need to say that, okay, this is an integer. Okay, so I will say write int, because I will write an integer data to my file. Then when I will say I will write a short data, then I need to say write short. I need to use this write short function to write the short data. Similarly, I have to use this write Boolean to write the Boolean data. For the string one, I should say write UTF to write this my string. And similarly for the Boolean, I should write it, for the float, I should write float. So this is important now. I'm writing this data as an integer, as a short. What it means is, however, how I keep it in the RAM, I will write it in my program. So now let's run this code. I will zoom out a little bit. Okay, where is it? We have we have one more. Yeah, okay, we have, I guess, one more. Let's see, what was this mistake? Do we have still mistake? No. Yeah, then I think we can run it now. And just to understand that our code is finished, I will just put here a print message, okay? And finished. Let's say done, okay? Okay, so now it's set done. Now let's look at our code, okay? I will just refresh this part to be able to see the document. So where is that? Yeah, it's here. So its name is some file one, which appeared here. When I click this, I will see something like this. As you can see, it's not for me to read. This is actually, it's gibberish a little bit, because this is for the program, for my computer to read. So let's try to read this document now, okay? Now I'll go back to here. And now what I'll do is, now I will, in a similar fashion, that's why I will make a copy paste, but actually I will delete last of it. Now I will create object input stream. Okay, I will zoom in a little bit. This is in. Then I will say this is in. This is a now object, not output stream, input stream, not file output stream, file input stream, and I will read the same file. I'm getting this error because I didn't import this library, so I have to also import them. And then, of course, I need to now change this part. So what I will do is, now this part, and I need to close it. I also want to put it before I forgot. All right. Now what I will do is I will read and then write it to file. So I can say read this in my file object, then when I'm reading it, I cannot say, okay, I'll just read. What I have to say is, okay, what was my first data? It was an integer here. Then I should read an integer there, not any other data. Okay, then this will, let me zoom in a little bit. So this will return me an integer actually. Then what was my second data? Let me zoom out a little bit also. It was a short. So then I should read a short data. And similarly, I should read a Boolean data. So I should call read Boolean. And I should, for the string, I should call in.read UTF. And also for the float, similarly, I should say, okay, read float. And then, well, we can just print it to see if we read it correctly, okay? So what I'll do is I will say x is equal to plus x, and I will do it for all my variables, so which is y, b, s, and f, and similarly y, b, s, and f. So let's see what we will get. So yes, now x is 5, y is 10, b is true, s is abc, f is 0.5. Now what I will do is actually, I will do one little change. I will first try to read the float one, okay? I just changed the order. But I didn't change my writing order. This is different. So I kept the writing order same, but in the beginning, instead of reading the first integer, I read float. What will happen? Same. Let's see what will happen. Nothing happened. Well, probably why not? Nothing happened. It tried to probably get into here. Let's run it again. Yeah, it says some problem. So what is here happening is, to better understand it, actually, I will just slightly change my data, okay, to better understand what we are doing with the binary data. Because the float operation has a very different format to keep in the data. For the ones that I will just do it in a simpler way. I will just say short and int. Okay, I will just write int short and then write short, and I will do it same for this. Okay, so I will delete all this line. I will simplify my data a lot. And just to show that, okay, it is still working correctly, I will first run it in a correct way. So I'm writing a short integer and then the short. And then I'm reading integer and then short. That should be correct. Let me run it again.
No, short,
what happened?
Oh,
thank you, yes. And it should be y, right? Yeah, thank you. So let's run it again. So 5 and 10, I'll just double check. 5 and 10. Now what I'll do is I'll just change their order. And then rerun it again. Okay, now it says x is 327,690 and y is 0. Now what happened here is, well, when you are dealing with the binary data, you really have to follow the order. I will provide a very quick overview of what is happening here to help you better understand what is going on. When we write the data, all right, integer, how many bytes is that? 4, yes. So we write 4 bytes data here. So, but I will write 5. So let's say each of my numbers represents 1 byte, okay? So here is what we have written to our file, 0005, okay? Each one represents 1 byte. Then I go to here, and then I write short. How many bytes is short? 2. So then my memory is 0005, and then 10. 10, I need to write in 2 bytes. In 2 bytes is, so which means you need to convert it to binary digits. And then, well, the first digit will be 0. The second one will be A. So in a hexadecimal one, you can say that it is, let's say, A, okay? So it is 10. So this is my file content, okay? This is what I write to my file. Then when I'm reading the file, what is happening here is, I said, okay, read a short, okay? So what we do is, short is a 2 bytes, so it takes these 2 bytes and then converts it to the short, which is 0. So then that's why, now I'll go back to go to console. That's why y is seen as 0. It is 0 because then, okay, why x is that large number? Because then I said, okay, read an integer, which is 4 bytes, and then I'll check it. Okay, I was here, and then this is what I have to read. So this is a real large number, considering that each of them is a byte. This is the reason that now I made it incorrect. And well, Java will not complain you. Like if you said, okay, instead of integer, I would just keep reading short. That would also work. Like I would say, let's say one more time, I will read short. Java will not complain about it because from its perspective, it's just 6 bytes of data. And then you want me to read 2 bytes and convert it to short. This is what Java is doing. So it will still do this. I will just read 3 shorts and then convert that data to this way. So then it will say, y is 0, x is 5, the other one is 10. Why is that? Now I'll go back to my code again. So this is y is the first short, which is this way. 0, 0. Yes, it should be 0. Then x is the second one, which is this one. 0, 5. Yeah, it should be 5. And the third one is 0a. It should be 10. So again, so to sum up, when you are dealing with data, when you are writing data as a binary format, you have to check, okay, what is data format type, and also you have to be sure that in the correct order so that you can read it in a correct way. Do you have any questions so far? All right. Then we'll do one more thing, which is, I'll go to here. Well, I created one game, okay? Since we didn't see graphical user interface yet, the game plays on the console, okay? So I will explain the game. Then what we will do is later on, we will see how to save that game and load that game, okay, by doing this I/O operations. So here is the game. I'm not able to zoom in, but okay, here's a screen, okay? Here's a map. This P is player, P. These W's are wolves, okay? And E is the exit part, that is at the top. And I need to control it. So it is controlled with WASD. W is up, A is left, S is down, D is right. And if I write save, it will save the file. If I load, doesn't work it yet, actually. And Q for queued, okay? So let me just play the game very quickly, a little bit. So every time it's a turn-based, so I will move, and then all the wolves also move, okay? And then if they catch me, I will be gone. Without being caught, if I reach E, I will win. This is the game, okay? So I'm going up. Every time it creates one more map. Again, we still didn't see the graphical user interface, but maybe, inshallah, once we see the graphical interface, maybe we can also make it more fancy game, okay? So I'm going up. Let's see. To the right, to the up. Oops, I'm very next to the wolf. I'll go down, up again. Okay, then I can move, I guess. I'm about to lose. No. Okay. I think I go away. Go away. That's all right. A game over. A wolf caught me. I was so close. Anyway. So what we will do is now I will first explain this code a little bit, and then I didn't. I implemented, but I deleted the save and load part. Okay, so that we will together write the save and load parts again. So here is my game. First, I need to explain it a little bit. I have this wolf class. Okay, a wolf has a position only. Okay, right in this map, this row and column RNC, and to keep the positions, I created this POS class, which also again keeps this RNC. The details are not, to be honest, very important. I will share the code, then you can check it if you want. This is not, but we should know that okay, it has this RNC rows and the columns for the position. Wolves has this position as an attribute. We have this player, which also has this position. And then this serializable, I will explain it when we are talking about how to write that data, okay? And then here's my main game. The details are not that important, to be honest. I will very quickly go over that. So I'm creating this game option, and then, so let's look at first our constructor, in which it generates 10 wolves, which is, if I go to here, so basically it generates some wolves, 10 wolves, and then randomly distributes it in our map. These parts I'm skipping it because you really don't need to know the details. We just need to know that what type of data we should write to save the file, and what we should data to need to load the data. Okay, so this is, but we have these. It creates that wolves for me, and then when we run it, we get it from the user. We ask from the user. This is something that I put from the, if we want to load the game, or if we want to start from scratch. If we define any file name, it will load. Otherwise, it will just start a new game, and then it draws the map. And then this is just in a while loop. We ask the user to provide the comment, and then if it is quit, we will quit. If it is save, we will save it. But these are not implemented yet. We will do it. Okay. So all these saves and loads are not implemented. And then, well, the user, based on our options, try to move, going up, left, or so. But then there are some checks that, again, it's not that important for us. If we are out of the map, and so on. And then if it checks if the player is caught. Otherwise, it moves the walls randomly, and so on. So for that game, but to load a game, what do we need? What do you think? If you had implemented a game, any game, and you want to save the game, what should we save?
The last position that we were in.
Okay.
A score, there's a score.
Scores. Actually, we can say a very more general name, which is like for any game, we have to, where is our attributes? Let me find my attributes actually, one of them. Yeah. I have to save my attributes. This is the status of my objects. Like how many wolves I have, where are those wolves, and where is the player, and for this game, that's it. Like if I know where the wolves is and where the player is is there, then that's it. So for each player also, what should I save? Well, for this game, if I had more attributes like name, score, whatever it is, but actually at the end of the day, it's just the attribute of that object. So I have to save those attributes. This is what a save file is. Okay. Then, okay, now let's start. Go to here. If the user hits the save part, okay. Oops, sorry. What happened? I accidentally deleted some part. I want to save the file as not a binary, but as a text file. What should I do? So just to make it short for you, I have three things to save. The wolves, where they are, the player, where it is, and also the end point of the game. Okay?
Write the instances to a file.
Yeah, we will write the file, but the thing here is, now it has to be a text file. So how can I create a save file for a game as a text file? This is the challenge that currently we are facing.
Take the attributes and parse them to a string, and then write.
Parse them to string and then write. Yes, exactly.
So what do you mean by parse it?
Convert it to string. Convert it to a string. Yes. So here I will actually copy paste my code for it. Okay. What I'll do is let me because I have only 20 minutes, I want to finish it in this lecture, okay? So I will just make a copy paste from my previous code. And then we'll go over that. So when we are writing to a text file, okay, then, well, I have to come up with a format because now I'm creating literally a text editor that human can read. So I should say, okay, in the first line it will be the player position, in the other line it will be wolf's position, whatever it is. But I have to come up with a format. So what I do is I create the file, and then I write the player's position, I print the exit location, I print the how many wolves I have. Maybe I don't know it, maybe it's 10, maybe 5. I should also know that. And then for each wolf, then I print their position. And then I just said, okay, the game is saved, and then I will close it. Okay? So this is one way. You can come up with some other ways, but with different orders. Maybe you will just put first the wolves, then the players, whatever you want, but you have a string formula to keep the data. Then, all right. Is this part clear for everyone? Should I proceed to next part? All right. For the binary case, if I want to save the data in a binary format, what should I do then? Now this is a text editor, but usually, like when you play a game and then you save it, if you try to open that file, you would not be able to read it because those files are not TXT files, they are binary files. This is how we usually do that. So normally this is not the norm that we save the games or so on. We usually save it as a binary file. So how should we do that then? Any idea currently what we have seen so far?
Find the ASCII value for each one. And then
Yeah, one way is, that's not an ASCII, but the thing is, I need to go to the player position. And what is a position for the raw integer? So I need to write, okay, for the player's row number, write an integer. For the column number, write an integer. And then for the wolves, how many wolves I have, write an integer. And then for each wolves, what's its row and column, write an integer. So but I need to be careful about its data type. That's one thing. But actually, it's pretty hard, because if you have so many attributes for each object, that would be really painful to write an object to a file. The good thing here is Java supports you can also write objects to the file as they are. You don't need to deal with, okay, what does its attribute? Is it 1? Is it 2? Is it integer? Is it boolean? We can literally say that I want to write this object. So I'll go back to, again, my code to copy paste and then to show it. Let me also copy paste this. And where is that? Where is my game? Oh, okay, it's here. So for the save binary part, now I will put this. Here's it is. I create my file first to open it, and then I can literally say write object, and then I put my player object, because this is the attribute of my game also. Like if I click this, I have this player attribute of my game. So I can write the player. I don't need to worry about it. What is the attributes of the player or so? I can just say, okay, write this player to the file. And how about the wall exit? I can also write it. How about the walls? I can also write it. Like now I will go back to my save file. Where is that? Sorry. Yeah. So I just need to say, okay, write object player, write object exit. And the good thing here is I don't need to write all the walls separately. I have an array list of walls, and I'll just say, okay, write that array list. That's it. So it's much easier for me that I'll just write the attributes I have, and then I'm done. Now what I will do is, let's run this code. Okay, we didn't load it yet. I know it. I'm aware of it. But I need to change the way I write it, the way I run it, okay? So what I will do is, let's first start from a null game, and then let's save it. And if it is true, it means that save it binary, okay? So I will first play one game, and I will go up maybe one more time. Okay, then it's in the third row, okay? Then I'll say, okay, save the game, and I will quit, okay? So I would like to continue from this third row. Please remember that. For the binary option, we are in the third row, okay?
Save it, you didn't write S.
Yeah, I think I thought that I had changed it, but I think I forgot it. Anyhow, yeah, when I say S, it also goes to downside. So there's a confusion. This message is misleading. I have to write save, actually. Yeah, I know that this message is misleading. Okay, what I can do is now, well, this was with true option, which means it will be a binary file. So I will refresh this part. And my file name is, or what is my file name? Let's look at it. When it is save, okay, it's save game dot dot. Okay, so I'll open that file, save game dot dot. Okay, here is what I have. It's again not readable for me. That is fine. This is the binary file itself. What I could do also is I could also, now I'm going back. I will play one more game, but this time it will be, I will write it to a text file, not a binary file, okay? So again, now for the binary file, I will go to the right so that we can know what is what. Okay, I'm in this fourth column, and then I will save the file now, and I will just quit the game. All right, now we have saved the file. For that one, what was our file name? I think it was savegame.txt. So when I open that, okay, here is the data. Like, where is my position? Where is my player? It's in the 9th row in the 3rd column. Where is the exit? It's the 1st row in the 9th one. How many walls I have? 10. And then these are the locations of my walls. Okay, so I had this kind of a very specific format. Now what I have to do is I have to load the file. So now let's think about how can we load the file, okay? Now let's write it here. Load here. Okay, this is this part. Sorry. I'm sorry. Where is? All right, here we are. Now I have to run this. Now I want to hear from you. What should we do? How can we load it? We write our player location, our wolf location, and the end game location, and so on. And we have this file. This is our file. Where is that?
We have to read the file
Okay.
and parse it and
All right.
assign. At first, we have to make every object null. We have to reset it, delete it, and then assign the objects to the new one.
Well, I don't need to delete it, but yeah, I need to change their score values. Then I will be well. So again, I will copy paste from my own code. Okay. So this is that. Let me copy paste it to here. So I'll explain, but we had seen the buffered reader, if you remember. So we are reading from the file. Okay, then we read one line, and then the first line, it represents the location of the user, of the player. So as you can see, I'm resetting this my attribute, player one, my attribute, with a new player, but I'm setting its attributes based on what I read. And then I read the second line, which is my exit position. So I also read it, and I set it to my exit position. And then I read another one, which gives me the number of wolves. Then I first make it clear, and then I go to how many wolves I have. And for each wolf, I read one more line, and then I add a wolf within that position. And then actually I'm done. I loaded all the data that I have written, so that now I can proceed. I can now, by using this load function, let's try if it will work. So I'll go to, again, my main code, then in which, yeah, this should be, which is I will use this file to load, and it's not a binary data. And let's see, it was in the non-binary one, I had moved to the right. Normally it starts at the left bottom, most left bottom. Let's run the code now. Yes, as you can see that it is now here, my player is here, so that I could really load the data from where I had left the game. All right, how many minutes we have 10 minutes, so that's good. Now let's go back and check how can we do it for the binary one. So for the binary one, what is happening here is when I run the code, where is it? I'll just briefly explain. If the file name is not null, if it is binary, I call load binary. And then load binary is, what should we do now? Because now what we will give is this file that we don't know what it is inside it. But we know how we have written the data in it. We have written the data as such. We have written player, exit, and the wolves. Then how should we load that data? Any idea?
We are reading the object immediately, so we don't have to convert anything.
Yeah, actually, kind of. So I have 10 minutes. So I can go a little bit slower for this one. What I will do is I will again take this part, copy paste it, and then I'll modify it here. Okay. So I will change all this part here. I need to open the file name based on whatever the load data name is. Okay. Then first, what I forgot to say that I have to say that can I write any document to any file, any object to any file? Well, actually, it's not the case. If you want to write a file, an object to a file, what you should do is in your class definition, we should say implements serializable. So any class that implements serializable interface, you can write it to a file. And the interesting thing is that this interface has literally no function in it. You just need to say that, okay, this implements serializable, and you are set. Then this object now becomes writable, okay? But you have to do it so that's why in my all class definitions I have this. Wolf implements serializable, position implements serializable, player implements serializable. So which means that actually I'm telling to Java that, okay, I will write these objects to the file, okay? But you don't need to do anything more. That's the beauty. You just need to call write object. That's it. And when I'm reading it, now the first object that I have written was, again, I have to be careful about the order, is the player. So I need to set the player. So I will say in.read object. But when I do it, this read object returns me the data as an object type. So I have to cast it to my player. I need to change this one more catch block for this one. Then what is my second object, which is exit. So then I need to say, okay, this exit should be also in.read object. And its type is, again, POS, pause. So I need to set it. And what is my third object, which is wolves. Wolves is, again, I'll just say wolves is equal to in.read object. The only thing, again, is I just need to convert it, which is, it is an actually list of wolves. So it's not a single list object. It's a list of wolf object. And I'm done. So that's the beauty of writing objects and binary objects. I didn't need to worry about, okay, how should come up with some string format to write and how to load it, parse the strings, set the variables. I literally don't need it. I just say, okay, I have a list of wolves, just load it. It will handle it. That's the good part of it. Now, I think I'm done. I hope I didn't do any mistake. Let's go to our main code. Oh, actually, we are already here, sorry. Then, well, now I will run my game with this binary data option. And that true means it's then now a binary file. So remember that in the binary version, we had go up to the, I think we had go 3 times. So I will run the code, and then let's see if we will be able to start from that position. Yes. We are not in the first, but in the second and third position. So yeah, we could continue from the game where we are, where we were, so that we can just continue playing the game. Do you have any question? Zero question? You just like the game? You want the game, play the game? Okay, I'll share the code, fine. All right, I think it's 10 or 2 for the 6. I'll stop here for today. I'll take the attendance, no worries. And then in the next lecture, we will start with the graphical user interface, and maybe, inshallah, we can turn this game into a more fancy version when we have this graphical user interface. Please log in your Blackboard so that we can take the attendance.